Welcome to Edubbey Global Solution. Again, in our mathematics class, we're going to be looking at another topic, which is our proportion. And under this topic, we are going to be looking at different type of proportion that we have. Then we're going to be having class activities and also examples with past questions related to the topic. Now, when you're talking about our proportion, a proportion is a what? Is an equation in which two equal ratios are equal to each other. So under proportion, we can refer a proportion to an equation in which two ratio sets equal to each other. And under proportion, we have two types of proportions that we're going to be looking at in this class. The first type of proportion is direct proportion, and the second is inverse proportion. And this is an illustration of direct proportion here. We have illustration of inverse proportion here. Okay, now what is direct proportion? A direct proportion is a relation between two quantities where the ratio of two is equal to the constant value. So the ratio, when you are dealing with a direct proportion, the quantity that we deal with, we equate it to a constant value, and the constant value we represent it as what? As k. Now under direct proportion, we have two quantities. We can denote those two quantities as s and y. As s increases, y increases. That is, the first quantity increases, the second quantity increases as well. And as the first quantity increases, the second quantity increases as well. So we denote it as y directly proportional to s, and by the time we are writing it as an equation expression, we have it as y equals to ks, where k is our constant value. Now for direct proportion, we can have our illustration for the graph to look this way. So as x increases, y increases, and as x decreases, y decreases, and we still have our k as the constant or proportionality of a given gradient of the graph. Now we have an example here. We are considering y equals to 1 over 2 s raised to power 3. Prepare a table for the value of x equals to 1, 2, 3, 4, 5, and then we have to plot a direct graph for this. So we have this quantity here, which is what? Which is x and y from that given equation. So we have to prepare the graph for when x equals to 1, we want to know the value of y. When x equals to 2, when x equals to 3, x equals to 4, x equals to 5, what is the value of y? So that implies that from this given equation, whenever you see x now, we are going to be replacing it with the figures we are given for s, which is 1 through 5. So let's see what happens. Y equals 1, y is 1 over 2, s raised to power 3. Now when x is 1, what is y? That is going to be 1 over 2 multiplied by 1 raised to power 3. 1 raised to power 3 will give us 3, right? So 1 raised to power 3 will give us 1. Now 1 multiplied by half, that is half. So when x is 1, y is 1 over 2. Okay, now when x is 2, what is y? When x is 2, y will be what? So y equals to 1 over 2, x raised to power 3 now. So we replace it with 2 raised to power 3. What is 2 raised to power 3? That is 2 in 3 places, which is what? 8. Now multiply 8 by 1 over 2, that is what? 8 over 2. How many times can 2 goes in 8? That is 4. So when x is 2, y equals to 4. Okay, now let's look at the third one. For the third one, what is x? X equals to 3, what is y? So we are 1 over 3. They have 3 raised to power 3, right? Because this is x. So we replace the x value with the value of x, which is 3. Now 3 raised to power 3 is what? 27. 27 multiplied by half will give us 27 over 2. So when x is 3, y is 27 divided by 2. Now for the other value, when x is 4, what is y? So y equals 1 over 2, 4 raised to power 3. What is 4 raised to power 3? 4 in 3 places. 4 times 4 times 4 will give us 64. So 64 multiplied by half, that is 64 divided by 2. How many times can 2 goes in 64? That is 32. So when x is 4, y is 32. Now the last one, when x is 5, y is what? So y equals 1 over 2, x raised to power 3. So we have 1 over 2 5 raised to power 3. What is 5 raised to power 3? That is 5 times 5 times 5. That is 125. So we have 125 times half will give us 125 over 2. So when x is 5, y is 125 over 2. So now we can try to plot that on a straight line, and we have our x-axis and our y-axis. So this is our x-axis, we have our y-axis like this. So now under that, if you divide 1 over 125 divided by 2, it gives us 62.5. Okay, 27 divided by 2 will give us 13.5. So the highest value of y that we can have here, we can have 65. Okay, now after 65, let's be reducing it in a range of 10. So we have 55. After 55, we can have 45. We have 35. We have 25, and we have 15. Okay, so now for the x value, let's have it from 1 to 5. 1, 2, 3, and 4, and 5. So we are, when x is 1, y is what? Y is 1 over 5. 1 over 2 rather. 1 over 2 can be changed to what? 0.5. That's the decimal point. So it's going to fall within the rate. When x is 1, y is 1 over 2. So we have this. It's less than 15. Assuming that we are having the normal graph to plot. Now, when x is 2, what is y? Y is 4. So we are going to be having it in this range. We're still going to be, okay, let the first value be here. So the second value is going to be here, 4, 2, and 4. And when x is 3, y is 13.5. So it still becomes 15 as well. So let's still have that. Now, when x is 4, y is 32. So it's going to be between 25 and 35. So we have 32. And when x is 5, y is 62. So we have this. So by the time we are plotting, assuming that we are plotting on a graph, we are supposed to have a straight graph. And that is an illustration of a straight graph that we have here. So we have x raised to the power of 2. And that gives us a solution to that class activity. So for the next slide, we have activity here. Direct proportion is relationship between two quantities where the ratios of 2 is equal to the constant value. Yes, as y increases, s increases, and as y decreases, s also decreases. So yes, we are right. Now let's check the two types of proportion that we have considered is what? We have direct proportion and indirect proportion. That indirect proportion, we can also call it inverse proportion. So those are the two types of proportion that we have. Okay, now that leads us to inverse proportion. Two quantities are said to be inversely proportional if an increase in one leads to a decrease in the other and vice versa. So let's have the two quantities to be something like x and y. So as y increases, s decreases, and as y decreases, s increases. So that's one thing about inverse. So as one is increasing, the other decreases. And we still have our constant proportionality, which is represented as k. Now we have it as y varies inversely as what? 1 over x. That's the inverse value of x, 1 inverse. So like the inverse, the proportionality sign changes to k. So k multiplied by 1 will give us k. So that way we have y equals to k over x. And that leads us to the graph also for inverse. As we have said that as y increases, what happens to x? X decreases for x1. So and as y decreases, what happens to x? S increases. Okay, now we have an activities here, which is also a past question. I'm going to be looking at it together. Y is directly proportional to x. So if y equals to 7, when x equals to 2, find y when x equals to 5. So what we need to do here is we have to change it to a direct proportional. So which is y varies directly as what? As x. So we change this sign to k because that's the proportionality sign. So we have equals to k multiplied by x, which is kx. Now from that given equation, they said if y is 7, so wherever you see y now, replace it to be 7. And what? X is what? X is 2. So we have k multiplied by 2. We want to get k out here. So it's going to be 7 equals to 2k. We need k out, so we divide both sides by 2. So k is going to be what? 7 over 2. Changing that to decimal point, we have it to be 3.5 equals to k. So we come back to this expression. wherever you see k now, instead of k now we are putting 3.5. So y equals to 3.5x. They now say that we should calculate the value for y when x is what? X is 5. So wherever you see x here, we are replacing it with 5. So we have y equals to 3.5 multiplied by 5. What is 3.5 multiplied by 5? That is going to be what? 17.5. And that is an example of proportionality type. We have this as dragging the right answer to the process, which we can actually do. Now let's look at another example of inverse proportion. Okay, for this inverse proportion, y is inversely proportional to x. So if y equals to 5, when x equals to 3, find y when x is 30. So what we just need to do here is what express this in an inverse proportionality for which is y varies inversely as what 1 over s. This the sign changes to what k, which is the proportionality sign. So we have y equals to k multiplied by 1 over x. So y equals what? K over x. Now when is what is y? Y is 5. Replace this with as 5. And k is what? We don't know k. We are looking for k. But x is what? X is 3. So we have k divided by 3. Now we cross multiply because we need to get the value for k. So we cross multiply. That's going to be what? 5 multiplied by 3 equals k. Okay, having that, what is 5 multiplied by 3? 5 multiplied by 3 will give us 15. So we have 15 equals k. Okay, now we come back to this expression. Wherever we have k now, we are replacing with that with what? We have 15. So y equals 15 over x. Now the value now says that what is y when x is 30. So wherever we see x here, we are replacing it with what? We are replacing it with 30. So y equals to 15 divided by 30. That is going to be 15 can go in 15 1 and 15 can go in 30 and many times 2. So we have 1 divided by 2. And this leads us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thanks for listening. See you next class.